Hi everyone, so we're going to go through a couple of questions, some GCSE probability, tree diagrams and Venn diagram questions, and we're going to go up in difficulty. Okay, so we're going to start off with a couple of simpler ones, and then we're going to work on to some harder ones. Okay, so start off question here, tree diagram. So James goes to an arcade. He has one go in the teddy grabber, one go in the penny drop. All irrelevant as far as I'm concerned. The probability that he wins on the teddy grabber is 0.2, that's important. The probability that he wins on the penny drop is 0.3, that's important. Okay, all of this is irrelevant. It's important in maths to take away the useless information and just decipher the useful information. Okay, so we know that each branch on a tree diagram needs to add up to 1, so we have 0.8 here. Okay, and the probability, so again, add up to 1, 0.7 here. And the probability that he wins on the penny drop will stay the same, 0.3. What's the reason for that? It's because the question has not told us otherwise. Okay, so they said probability of winning on the teddy grabber is 0.2 and winning on the penny drop is 0.3. Okay, so this is 0.3 and this is 0.3. The question doesn't say otherwise, so we can assume that it's also the same. Okay, these events are independent of one another. And because this is 0.3, we know this is 0.7 as well. And having a look at part B, probability that James will win on the teddy grabber and also win on the penny drop. Okay, so because it's and, we need to times, because we know in probability whenever we see and, we times, and whenever we see or, we're going to be adding. Okay, so wins on the teddy grabber is 0.2, and then again wins on the penny drop is 0.3. Okay, so it's going to be 0.2 times 0.3, which is 0.06. Okay, so let's have a look at the next one. A bag contains counters that are red, blue, green or yellow. Counter is chosen at random. The probability that it is red is 9 out of 100. Work out the probability that it is green. Okay, so we know the probability that it is red is 9 out of 100, and in probability we always have the total on the bottom. So we know the total number of counters is 100. And these columns give us the number of counters. Okay, so when we add them together, we should get 100 counters. Okay, and at this point it just becomes an algebra equation. 3x plus x minus 5. It just becomes a linear equation at this point. Plus 2x equals 100. 3x plus x plus 2x is 6x, and 9 minus 5, be careful with the minus sign, is 4 equals to 100. Subtract 4 on both sides. 6x equals to 96. And then divide both sides by 6. You should get x equals to 16. Okay, but we're not done yet. It asks us for the probability that it is green. So we know x is 16. So x minus 5 is the number of green counters. So 16 minus 5 is 11. So there's 11 green counters. And the probability, again, as I mentioned before, is always over the total. So it's going to be 11 over 100. Okay, so let's have a look at the next one. The Venn diagram shows the number of Year 9 pupils which has selected either French or Spanish GCSE. So here we have the Spanish circle. So everybody in this circle studies Spanish. Here's the French circle. Everybody in this circle studies French. The people who are in this part, the overlapping section, study French and Spanish. Okay, the 16 people here only study Spanish, and the 10 people here only study French, and there's 4 people who don't study Spanish or French. Okay, 4 people here that don't study those languages. Okay, so let's have a look. Part A, not studying French GCSE. Okay, so everybody in this circle studies French, so everybody outside of it doesn't study French. So we have the 16 and the 4. So there's 20 people who don't study French, and that's out of the total, which I believe is 36. Okay, so not studying either Spanish or French. I don't like the way these are phrased. They're quite vague, but I'll take it to mean the negation of Spanish or French. Okay, so everybody in this circle, well, everybody in this section here studies Spanish or French, right? People study here only study Spanish. People here study Spanish and French, and the people here study just French. But everybody in this circle studies Spanish or French. So the people who don't study Spanish or French are the 4 people outside here. So it's everybody outside that figure of 8 thing, this thing here. Okay, so it's 4 people who don't study out of the total, which is 36. Okay, and again, you should be simplifying these. So 20 out of 6 is, let's finish this one first. Okay, part C is studying both subjects. So as I mentioned at the start, the 6 people in here, they're in the overlap section. They study Spanish because they're in the Spanish section, and they study French because they are in the French section as well. Okay, so it's 6 out of the total, which is 36. That simplifies to 1/6. 4 out of 36 is 2 out of 18, which is 1 out of 9. And 20 out of 36, this is really testing me now, 10 out of 18, which is equal to 5 out of 9. Okay. Okay, so we'll have a look at the next one. Close that there. So A and B are 2 sets of traffic lights on a road. The probability that the car is stopped at light A is 0.4. Okay, so let's just stop there and let's just put that in. 0.4 is stopped at light A. So straight away we know not being stopped at light A is 1 minus 0.4, which is 0.6. And again, we see the pattern of that tree diagram. We know that the branches next to each other always add up to 1. These will add up to 1, these will add up to 1, and these will add up to 1 as well. Okay. So now, if the car is stopped by lights A, so it means we've gone down this part of the Venn diagram, the tree diagram, then the probability that the car is not stopped by light B is 0.7. So we know not stopped by light B is 0.7, so we can work this out now to be 0.3. Okay, we can't just now assume that this is the same because there's more information given to us. Okay, these events are dependent on one another. Okay, whether you get stopped at light A or not will affect whether you get stopped at light B. If a car is not stopped by lights A, so now we've gone down this part of the tree diagram, then the probability that the car is not stopped by light B is 0.2. So we know we have 0.2 in here. So we must have 0.8 here. And now they are asking us, Mark drove along this road. He was stopped by just one of the sets of traffic lights. Is it more likely that he was stopped by light A or light B? Okay. So the probability that he was stopped by light A is 0.4. The probability that he was stopped by light B, so this says, actually here, it says that he was stopped by just one of the sets of traffic lights, okay? So if he was stopped by just one of the sets of traffic lights, it means if he gets stopped by light B, he can't be stopped by light A. Okay, so so in order to get stopped by light B, he must not have gotten stopped by A and then gotten stopped by B. Okay, which is 0.6 times 0.8. Okay, and the reason for that is because he was stopped by just one of the sets of traffic lights. If he was stopped by A and then stopped by B, he would have been stopped by 2 sets of traffic lights. Okay, so the answer to that is 0.6 times 0.4. Fine, I should have known that. 0.0. My year 6 numeracy skills on display there. Okay, so it is more likely that he is therefore going to be stopped by light B because 0.48 is bigger than 0.4. Okay, so let's have a go at the next one. Okay, so we have numbers. S is square numbers, E is even numbers. Complete this Venn diagram. Okay, and we begin the set of these 12 numbers here. Okay, so what I can recommend for this is to circle the square numbers, remembering that 1 is a square number because 1 squared is 1. 4 is a square number and 9 is a square number, and we can do in green all the even numbers. So 2, 4, 6, 8, 10, and 12. Okay. So now I always recommend whenever you're using a Venn diagram, start off in the intersection in the intersection part first. Okay, so here it's going to go for all the numbers that are square and even, so all the numbers that have a red circle and a green circle around them, and there's only 4. Okay, so 4 is the only one. Okay, Now we can put the rest of the square numbers here. So it's all the odd square numbers, so 1 and 9, because they're not even, they're not in the even circle. And now here go all the rest of the even numbers. So 2, 6, 8, 10 and 12. And of course we have the numbers out here that are not square and not even. Okay, so they're not square numbers and they're odd numbers. So we have 3, 5, 7 and 11. Okay, so the question is asking us, because I managed to cut it off, you can't see the bottom of it here. So the question is asking us, what is the probability? So one of the numbers is chosen at random. What is the probability that the number is square and even? Okay, so the probability that the number is square and even. Okay, so a typical mistake here would be to write 4 over 12, because 4 is in the middle and there's 12 total numbers. But unfortunately that's not correct, because now we need to think about the number of numbers that are here, and there is only one number in here. Okay, so there's one number that's square and even out of a total 12 numbers. Okay, so the next question asked, write down the numbers that are square and odd. Okay, so square and odd. Okay, so to be odd, it means you can't be in the even section. Okay, because any number that's not even is odd. Okay, so we're not allowed to be here, and we have to be a square number, so we have to be here. Okay, so it's 1 and 9. So there's 2 of them out of a total 12, and that is 1 out of 6. Okay, so let's go to the next one. So we have 40 students were surveyed. 20 have visited France, 15 have visited Spain, and 10 have visited both France and Spain. And we've been asked to complete the Venn diagram. So anytime we're filling in a Venn diagram, we always must start from the middle. Okay, so let's start from these 10 that visited France and Spain. Okay, so 10 of them definitely go here. Okay, so if 10 of them go here, and the 20 visited France, so 20 people need to be in this France circle here. So we must have an extra 10 here, okay? Because we know that the France circle should have 20 people in it, because 20 people visited France, 20 people should be in this circle, and 10 of them are already here. So 10 must be there. And again, using that same logic, 15 have visited Spain, so 10 of them are already there, so 5 of them are here. Now we need to remember as well that there was 40 students surveyed, and some of them didn't visit either country, so 10 is 20, plus 5 is 25, so 15 must have not visited either. Okay, so nice little Venn diagram question there. And I'd always recommend to start from the middle, because if we didn't, which is a common mistake, so if we started off here, 20 have visited France, so if we say this is France and Spain, if we put 20 here, and 15 visited Spain, if we did 15 here, and say we did 10 have visited France and Spain, 10 here, and then straight away 20 plus 10 is 30 plus 15 is 45. So can't be 45 because only 40 students were surveyed. Okay, so that's why we start from the middle and we work our way outwards. And that's exactly the same for when you deal with triple Venn diagrams in A-levels, and I believe possibly in GCSE, I'm not too sure. But if you deal with a triple Venn diagram, it's exactly the same. You start from the middle, and then you go for these sections here, and then finally you do these sections here. Okay, so let's have a go at the next one. An activity camp has a climbing and sailing classes. 50 children attend the camp, so 50 in total. 35 children do climbing, 10 do both, and 2 children do neither. Okay, so we're going to do a Venn diagram here. Absolutely terrible circles, but please forgive me. So 50 people in total, and again, so we're going to start from the intersection part. So we're going to start from the people who do both. Okay, so there's 10 children here who do both, and if there is 35 who do climbing, I should have mentioned this was climbing and this is sailing. 35 children do climbing, so there needs to be 35 people in this circle here, and 10 of them are already here. So 25 must be here. And now we know that 2 children do neither classes, so 2 of them are here. So at this point now we think, what goes here? Because they didn't tell us anything about the sailing, people who do sailing here. But that information will come from the fact that there's 50 children in total. So we know that 25 plus 10 plus 2 plus this number needs to be 50. And it turns out that this, I believe, is 13. Okay. 13 plus 2 is 15. 15 plus 25 is 40. Plus 10 is 50. Perfect. Okay, so we've done that. Again, starting from the middle, working our way out. Okay, so on Friday, Greg takes part in a long jump competition. He has to jump at least 7.5 meters to qualify for the final on Saturday. He has up to 3 jumps to qualify. If he jumps at least 7.5 meters, he does not jump again on Friday. Each time Greg jumps, the probability that he jumps 7.5 meters is 0.8. Okay, so assume each jump is independent. So this is the important part. A lot of it is not really important, but I don't want to cross it off because I will have to read it again. So the probability that he jumps at least 7.5 meters is 0.8. Each jump is independent. Okay, so whether you qualify or don't qualify on one jump does not affect, well, whether you jump 7.5 or don't jump 7.5 meters will not affect your ability to jump 7.5 meters on the next jump. Okay, so the probability will always stay as 0.8. Okay, so the probability that he qualifies is 0.8, and we know we have to add it to make to 1, so 0.2 for not qualifying, but he can then try again if he doesn't qualify. So we have qualify and then not qualify, and again the probability are the same, 0.8, 0.2, and then if he doesn't qualify again, he can try one more time, qualify, not qualify, and again probability he qualifies is 0.8, and the probability that he doesn't qualify is 0.2. Okay, and of course we don't have branches coming off here, because if you qualify you don't need to jump again, so there's no need to put branches off the qualify section, or off the qualify branches. Okay, now work out the probability that he does not need the 3rd jump to qualify. So what this means, if he doesn't need to do this jump, it means he qualifies on the first one or the second one. Okay, and notice I said or there. So the probability that he jumps on the first one, so I'll just put P bracket first. This indicates probability of him qualifying on the first is 0.8. And the probability that he qualifies on the second is not 0.8. Because we need to remember, when we go along a tree diagram, tree diagrams talk about successive events that happen one after the other. So in order to get here, you need to start from here. You need to work your way along here and then go up here. Okay, so we can't just say this is now 0.8, despite the fact that qualifying is 0.8. But now this is the probability that he qualifies on the second jump. So he doesn't qualify on the first one, and then he qualifies on the second one. Okay, we know we need to times when we go along. So this is going to be 0.2 times by 0.8. There, and then we add them together, because as I mentioned before, this is the probability that he qualifies on the first or he qualifies on the second, so we're going to be adding these together. Okay, 0.2 times 0.8, 0.16, 0.16 add 0.8 is 0.96. So the probability that he does not need the 3rd jump to qualify is 0.96, so it's quite likely. Okay, so let's have a look at the next one. All of the members of a club were asked if they eat apples or bananas. The information was represented on a Venn diagram. How many people are there in the club? Okay, so just adding them together. And I've got it here. It's 130. Yeah, 17 plus 52 plus 20 plus 41. 130. A member of the club is selected at random. What is the probability they eat both apples and bananas? Okay, so the people who eat apples and bananas are in this part of the Venn diagram. Okay, they're in the apple circle and they're in the banana circle. So it's 52 people out of 130. Okay, which should simplify to, I believe, 26 out of 65. Yes, 26 out of 65. Okay, let's have a look at the next one. Village of Sumston is organising a spring fair, I presume that means fair, to raise money for the local community centre. And they've given us the prizes and the probability of winning each prize. In the lucky dip, everybody wins either a toy or a pencil. This is going to come useful for later, but at the moment it's not that useful. The probabilities of winning the prizes are given in the following table. Find the value of x. Okay, so it always annoys me they mention stuff like this because we can see the table, so I don't know why they mention that. So to me, that's not really that useful. Find the probability of x. Well, we know that the maximum probability we can have is 1. Okay, so when we add these probabilities together, we should get 1. Okay, so we know x plus 3x plus 16x is equal to 1. Adding the x's together, 20x is equal to 1. X is equal to 1 over 20. Okay, so that's the value of x. So now in the raffle, a free second ticket is given with every ticket bought. Stefan thinks the offer will double his chances of winning a prize. Is Stefan correct? You must explain your answer. Okay, so have a think. Pause the video if you like, because it's an interesting question to think about. So if you've paused the video, welcome back. So I wouldn't say so, because a free second ticket is given with every single ticket bought. So everybody who buys a ticket will automatically have 2 tickets. So it will cancel itself out. And because of the fact that everybody either wins a toy or a pencil. So everybody who enters will have 2 tickets and will win something, because everybody will win a toy or a pencil, like they give it out for free. Okay, so everybody has 100% chance of winning something, so it isn't going to increase poor Stefan or Stephen's chances of winning, because the same thing happens to everybody, and everybody wins something as well. Let's have a look at the next one. There are 3 different types of sandwiches on a shelf: 4 egg, 5 cheese, 2 ham. Erin takes 2 of these sandwiches. Work out the probability she takes 2 different types of sandwiches. Okay, so she's going to be taking different sandwiches, and a tree diagram will be very, very useful to help us work out the probabilities here. So we have 3 options: egg, cheese, ham. For her first pick, and then her second pick again, she's got 3 options: egg, cheese, ham, egg, cheese, ham, egg, cheese, and ham. Okay, the probability she chooses egg is 4 out of the total, which is 11. The probability she chooses cheese is 5 out of 11, and the probability that she chooses ham is 2 out of 11. Okay. Here we have egg, cheese, ham, egg, cheese, ham, egg, cheese, and ham. Okay. So once she's taken an egg sandwich, how many sandwiches are there now in total? There was 11, and she's taken 1, so now there's 10. Okay, so we know all of these probabilities are all going to be out of 10. Okay, out of 10, 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 out of 10. Okay, because this is her first pick and now this is her second pick. So now we know all of these are going to be out of 10, because in order to get to one of these, you have to have gone through one of these, and thus you have to have taken 1 sandwich. So the total is now 10. So in this scenario, she's taken an egg sandwich. So now there's only 3 egg sandwiches because there was 4 before. Cheese and ham will still stay the same. 5 out of 10 and 2 out of 10. And if you notice as well, should add to 1. 3 out of 10, 5 out of 10, 2 out of 10 adds to 10 out of 10, which is 1. Okay, so now in this scenario, she takes a cheese sandwich. So what's the probability that she takes an egg sandwich? Well, it's still the same because she didn't touch the egg sandwiches, but the cheese sandwiches now on this second go has changed. Should be 4 out of 10 because there was 5 and she took 1. Ham stays the same, and the same goes for the last one, 4 out of 10, 5 out of 10, and they haven't changed, but ham has, because there was 2 and she takes a ham, so now there's 1. So again, they should add to 1 and these should add to 1 as well. Okay, so now work out the probability that she takes 2 different types of sandwiches. Okay, so what we could do is go and list all the different ways she could take 2 sandwiches. Okay, so she could take egg and then cheese. She could take egg and then ham, or she could take cheese and then egg, or she could take cheese and then ham, or she could take ham and then egg, or ham and cheese. There was a lot of different probabilities there, but you can go through one by one and work out each branch individually. But a quicker way to do this question is think about the branches that we haven't covered with the black colour now. Well, we have this branch here, egg and egg. We have this branch here, cheese and cheese. And we also have this branch here, cheese and ham. Okay. So what we could do is work out the probability that she gets egg and egg, which is really easy, 4 out of 11 times 3 out of 10, which is 2 out of 110. And then do the same for the cheese. So we're just to clarify, we're just going through the branches that we haven't covered in black. Okay, so cheese and cheese is 5 out of 11 times 4 out of 10, which is 20 out of 110. And then we could do the same thing for ham. So ham and ham equals 2 out of 11 times by 1 out of 10, which is 2 out of 110. Okay, and now we can add these together. And what we get is 34 out of 110. And now what we can do is we can minus this from 1, because we know all of the branches, if you find the probability of every single branch here and you add them together, they should get 1, because we know our maximum probability is 1. Okay, so we can just find the branches that are not shaded in black and minus it from 1. Okay, that's a much quicker way of doing that. So we should get 76 out of 110. But by all means, it's good practice to go through each branch and practice adding them up. So go through the all the combinations I said first and check do you get the same answer. But you should get 76 out of 110. Okay, so let's have a look at the next one. The diagram below shows the number of elements in sets A and set B. Given that this is 64, find the value of x. Okay, so little symbol appears up here as well. So we can assume that this means the total of all the elements in the set. Okay, so we have total 64. And we know if we add them together, we should get 64. Okay, so if we do x plus 6 plus 2x plus 3x minus 12, we should get 64. Okay, so that simplifies to 6x minus 2 equals to 64. So 6x equals to 66. So therefore, that should be x. X equals to 11. So find the probability that a randomly selected element is in set A. Well, we know x is 11 now, so x plus 6 is 17. And we know 2 times x is 22, and these are all the ones in A, so they're just the ones we care about. So the answer here is 17 plus 22, which is 39. But remember, we need to divide it by the total number of elements in the set, which is 64. Okay. So let's have a look at the next one. Okay, so let's sort this out. Sorry for this. This is Hannah's Sweets. It's off the page a little bit. There we go. So, infamous GCSE question. Hannah's Sweets, if you Google this, you'll see it was in all the news and everything. People were outraged with this question because they said it was so hard. So it tells you about n sweets in a bag. 6 are orange, the rest are yellow. She takes a sweet at random and she eats a sweet, and she takes another sweet at random and then she eats a sweet. The probability that she eats 2 orange sweets is a third. Show that n squared minus n minus 90 is equal to 0. Okay? So again, she's taking something and she's eating it, and she's taking something again and she's eating it. Okay? So these events are happening one after the other. Okay? So a tree diagram would really, really help in this situation. Okay? So let's make a tree diagram for her first pick and her second pick. Okay? So we'll put this orange, yellow, orange, yellow, orange, yellow. Okay, because we know there's only orange and yellow in the bag. 6 are orange, the rest are yellow. Okay, so let's think now, what's the probability that she gets an orange sweet? Well, 6 of them are orange and the total number is n. So probability she gets an orange is 6 out of n. Okay, let's say she ate this sweet now, and now she chooses another orange one. Well, she ate 1 orange, so now there's 5 orange, and the total now is whatever the total was before, take away 1, so n minus 1. Okay, and you can fill out the rest of the branches yourself for good practice, but all we need is the probability that she takes 2 orange, because we've been told that it's a third. Okay, so now when we know when we go along a tree diagram, we multiply. So we know that 6 over n times by 5 over n minus 1 should be equal to a third, because they told us in the question the probability of getting 2 oranges is a third. Okay, so now how do we times 2 fractions? We times the top and times the bottom. 6 times 5 is 30. N times n minus 1 is, we can just leave it as n bracket n minus 1, close bracket, equals to a third. Okay, so now we want to get rid of the denominator on the right hand side. So 1 is being divided by 3. The opposite of dividing by 3 is timesing by 3, and whatever we do to one side we also have to do to the other. So we times both sides by 3. Times by 3 and divide by 3 cancels out. They're the opposite of each other. They cancel each other out. 30 times 3 is 90. And this is n over, this is n bracket n minus 1. And this is equal to 1, because we're just left with the 1 from here. Okay. Now we want to get rid of this denominator, so we can times both sides by n bracket n minus 1. Okay, and again timesing this by n bracket n minus 1. Okay, cancels each other out, because timesing and dividing are the opposite of each other. So we're just left with 90 is equal to 1 times by this. And 1 times anything is just the thing itself. And now we can expand the right hand side. 90 equals n squared minus n. And now what we can do is we can minus 90 from both sides. Okay, minus 90. Minus 90, 90 minus 90 is 0, n squared minus n minus 90, and we are done. That is Hannah's Sweets. Okay, so obviously it's a bit more than just a tree diagram here. It's a bit of rearranging this equation here. So I suggest if you found this a bit tricky, just go have a look at a couple of videos on Haggerty Maths, Exam Solutions, Math Genie, about rearranging equations, just to strengthen your algebra a little bit. But there we go, that's Hannah's Sweets. And of course, I mean, like, we could put the equals on the other side now. Like I could, on the next line, I could just write n squared minus n minus 90 equals 0. It's exactly the same thing as that. They're all the same thing. Okay, so that's Hannah's Sweets done. I'll take away the other one as well. Okie dokie. So next one. Training agency awards a certificate to each student who passes a test while completing a course. Students failing the test will attempt the test up to 3 times more, and if they pass the test, they will be awarded a certificate. Okay, useless, don't like it. That's okay. The probability of passing the test at the first attempt is 0.7, but the probability of passing reduces by 0.2 after each attempt. Okay, so let's fill out the tree diagram. So 0.7, we know 0.3 needs to go here because they need to each branch needs to add up to 1. Okay, now the probability of passing reduces by 0.2 at each attempt. So the probability of passing here was 0.7, And now the probability of passing has changed. It's gone down by 0.2, 0.5. Okay, so we know it needs to add up to 1, so it's 0.5 as well. We can also view it that the probability of passing has reduced by 0.2, so the probability of failing has increased by 0.2. Okay, or easier way to do it is just make sure that you know that each branch has to add up to 1. Okay, so we've got 0.7 here, and now the probability of passing has reduced by 0.2 again, so 0.3 take away 0.2, just 0.1, and we know it needs to add up to 1, so we have 0.9 here. A student who's completed the course is selected at random. Find the probability that the student was awarded a certificate. So in order to be awarded a certificate, you need to either pass the first time, or failed and pass, or failed and pass, or failed and pass. Okay, I'm actually contemplating why I cross this out. I guess it's not that useless because we want to find the probability that they were awarded a certificate, and they were only awarded a certificate if they passed, but I think that's kind of common sense. Okay, so let's work out the probability that they passed on the first attempt, which is 0.7, or they failed and pass, which is 0.3 times 0.5. And remember, we can't just say this is 0.5 now. We can't just say the probability that they pass on the second attempt is 0.5, because we must remember, whenever we use a tree diagram, we must start always from here. Okay, and tree diagrams talk about events that happen one after the other. So in order to get here, you must have failed the first time. Okay, so or we could failed and pass, which is 0.3 times 0.5 times 0.3, or failed and pass. Okay, 0.3 times 0.5 times 0.3 times 0.1. Okay, and because we have or here, we know we need to add all of these things together. Okay, so calculate this, calculate this, calculate this, calculate this, and add those four numbers together, and you should find that you get 0.9055. Okay. So let's have a look at the second last question now. I think it's the last one. So let's have a go at this last one here. I think it's just, yeah, you can just see it, so we can work on it. The partially completed tree diagram where P and Q are probabilities give information about Andrew's journey to work each day. R represents raining, W is walking, B is busing, and C is cycling. Okay, and just for anyone who doesn't know, probability, if you have a dash next to it, it means that the negation of that event, so this just means not raining. Okay, given that PB equals 0.26, so this just means the probability that he took the bus to work. Find the value of P. Okay, so let's have a look at the tree diagram first. We know this is P, so we know, how do we work out this? Well, let's think about it. If this was 0.8, we would know straight away that this is 0.2. How do we do that? Well, we took this and we did 1 minus this quantity here. So let's just do exactly that. So it's 1 minus P. Okay, so you just need to learn how to treat letters like numbers. We know that this is 0.4, so we must have 0.6 up here. And in fact, we don't need to fill this one out, but we will anyway, just for the sake of the question. So we know this is 1 minus Q minus 0.15. Okay, we can simplify that to 0.85 minus Q. Okay, so we filled out the Venn diagram now, the tree diagram, and now we need to find the value of P. Well, we know the probability that he takes the bus to work is 0.26, so let's work that out now. So to take the bus to work, we either go along here and then along here, or I'll do another colour actually, or we could go along here and then along here. There's two ways to take the bus to work. Either it rains and he takes the bus, or it doesn't rain and take the bus. Okay, so let's work out each probability. So we know we times when we go along, so this is p times 0.4, and that is 0.4p. And now in black, let's do the other one. So this is 1 minus p times by 0.15. So I'll just put the 0.15 to make it easier, and I'll put brackets 1 minus p, because I know it's all of this times by this. So now I actually need to expand the brackets here. Okay. If I didn't put brackets there, let me just... If I put 0.15 times by 1 minus p, I might just think that it's 0.15 times 1, which is 0.15 minus p. But that's not correct, because we need to times all of this quantity by all of this quantity. Okay, so we have to expand out the brackets here. So 0.15 times 1 is 0.15. 0.15 times minus p is minus 0.15p. Okay, so now we're nearly there. So we could either go along here or go along here. And we know when we have the statement or, we need to add. Okay, so we know that this quantity plus this quantity is equal to 0.26. Yeah, because we've been told that the probability of B is 0.26, and there's two ways to getting to B, here or here. And this red way is 0.4p. This black way is 0.15 minus 0.15p, and we know we have to add them together to get to 0.26. Okay, so let's just do that now. So now let's write it out in one equation. 0.4p plus 0.15 minus 0.15p is equal to 0.26. Okay, and we know that 0.4p minus 0.15p is 0.25p plus 0.15 is equal to 0.26. And now subtracting 0.15 on both sides of the equation, we get 0.25p is equal to 0.11. And now last step, dividing both sides by, oh, I should have written 0.25 there, just a mistake there. So now dividing both sides by 0.25, we get p is equal to 0.11 divided by 0.25, which when you put that in your calculator, you should get 0.44. And now we're done. So I'll actually just let you know that question and this question, both A-level questions, and quite tricky A-level questions at that. Obviously only the first part of them, but fantastic work. So if you've been able to follow along, excellent. If you got stuck at any points, mention in the comments below and I'll try and help you out. Go along to Haggerty Maths, Maths Genie exam solutions for any help with any of these topics. And I hope this helped. Thank you very much. And don't forget to like, comment and subscribe. Thank you.